I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on chemical equilibrium. Before us, a typical A-level chemistry question on chemical equilibrium. In an experiment, 2.00 mole of hydrogen and 3.00 mole of iodine are heated together in a sealed container and allowed to reach equilibrium at a fixed temperature. The container had a fixed volume of 1.00 dm cube. At equilibrium, there were 2.40 mole of iodine present in the mixture. So if you look at the equation, 1 mole of hydrogen reacts with 1 mole of iodine to give you 2 moles of hydrogen iodide. What is the value of the equilibrium constant, Kc? So the first thing we need to do, we need to consider the initial moles of the reactant and the product. Initial moles of hydrogen is 2.00. Initial mole of iodine is 3.00. Then for hydrogen iodide is 0. Then let's calculate the equilibrium mole. Equilibrium mole for each of the reactant and the product. So at equilibrium, there were 2.40 mole of iodine present in the mixture. So at equilibrium, iodine is what 2.40 mole. So we have to calculate the equilibrium moles of hydrogen and what hydrogen iodide. Now what happened is that what if there were 2.40 moles of iodine present at equilibrium, so how many moles of iodine must have reacted? So it will now be what 3 minus what 2.40. So let me use my calculator. 3 minus 2.40, which is equal to what? 0.6 moles. That means 0.6 moles of iodine must have what? Reacted. Reacted. So if you look at the equation, let's look at the stoichiometry of the equation. From the stoichiometry, when 1 mole of iodine reacts, 1 mole of hydrogen reacts. So when 1 mole of iodine reacts, 1 mole of hydrogen also what? Reacts. So when 0.6 moles of iodine reacts, how many moles of hydrogen must have reacted? So it will now be what? That means 0.6 moles of hydrogen also must have what? Reacted. So to get the number of moles of hydrogen that is left at equilibrium, it will be 2 minus 0.6. So if I'm to use my calculator, 2 minus 0.6 minus 0.6 is equal to 1.4. So 1.4 moles of what? 1.4 moles of hydrogen will be left at equilibrium. Then, if you look at the stoichiometry between iodine and hydrogen iodide, 1 mole of iodine reacts, 2 moles of hydrogen iodide is formed. So when 0.6 moles of iodine reacts, how many moles of hydrogen iodide will be formed? So you cross multiply. So it will be 0.6. You have 0.6 times 2, which will be equal to 1.2. I think I have to confirm it from my calculator. 0.6 times 2, which is equal to what? 1.2. So 1.2 at equilibrium. So therefore, I think I have to erase that. I'll have enough space. Let me erase this so that I'll have enough space. Okay. So for hydrogen, the equilibrium mole is 1.4. 1.4. For iodine, the equilibrium mole is 2.40. For hydrogen iodide, the equilibrium mole is what? 1.2. So the container had a fixed volume of 1 dm cube. That is the volume. So we have to calculate what the equilibrium constant. So equilibrium constant Kc, I have to write the equilibrium expression, will be equal to concentration of hydrogen iodide all raised to power 2 divided by what? Concentration of hydrogen multiplied by what? Concentration of what? Iodine. So equilibrium constant Kc will be equal to concentration of hydrogen iodide raised to power 2, which is 1.2 divided by 1, which is concentration, all raised to power 2 divided by concentration of hydrogen, which is 1.4 divided by 1 times what? Concentration of what? Concentration of iodine, which is 2.40 divided by what? 1. So I have to erase this so that I'll have enough space to solve. So let me erase this. So equilibrium constant Kc now will be equal to, some to use my calculator, 1.4, 1.2 square, 1.44 divided by 1 is 1.44 over 1.4 divided by 1, which is 1.4. So 1.4 times 2.40 divided by 1 is 2.40, 2.40. So you have 3.36, which will now be equal to, so 1.44 divided by 3.36, 1.44 divided by 3.36, which is equal to what? 0.42857. So that is the equilibrium constant Kc. So the answer to this question will be what? C, which is 0.429 approximately. 0.42857 is equal to 0.429 approximately. So the correct answer to this question is what? Is C. So it's as simple as what? A, B, C. Attempt as many questions as possible and feel free to reach out to me if you encounter any challenge or any difficulty. I'm Mr. Joseph, your chemistry teacher. I'm always there for you. So feel free to reach out to me. I'm Mr. Joseph, your chemistry teacher. So thank you very much. I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on chemical equilibrium. So before us, a typical A-level chemistry question on chemical equilibrium. Hydrogen iodide dissociates into hydrogen and iodine. From the equation, 2 moles of hydrogen iodide gas dissociate to give you 1 mole of hydrogen gas and 1 mole of iodine gas. In an experiment, B mole of hydrogen iodide were put into a seed vessel at pressure P. At equilibrium, X mole of hydrogen iodide had dissociated. Which expression for Kp is correct? Kp is the equilibrium constant in terms of partial pressure. Now, the first thing, I have to write down the initial moles for the reactant and the product. So the initial mole for hydrogen iodide is B. Initial mole here is 0, 0. Then let's get the equilibrium mole. The equilibrium mole, from the equation, they say X mole of hydrogen iodide had dissociated. That means X moles of hydrogen iodide gas are what? Reacted or dissociated. So the number of mole of hydrogen iodide that will be left at equilibrium will be equal to what? B minus what? X. So we have to get the equilibrium mole for hydrogen gas and iodine gas. Now, if you look at this stoichiometry, 2 moles of hydrogen iodide gas dissociate to give you 1 mole of hydrogen gas. So if X moles of hydrogen iodide gas dissociate, how many moles of hydrogen gas will be left? So you cross multiply. You now have, we now have X over 2 moles of hydrogen. So at equilibrium, we'll have X over 2 moles of hydrogen. Now, if you look at the stoichiometry again, 2 moles of hydrogen iodide gas dissociate to give you 1 mole of iodine. So if X moles of hydrogen iodide gas dissociate, how many moles of iodine will be left? So you cross multiply. So you now have X over 2. So we now have X over 2 moles of what? Iodine gas at equilibrium. So the next thing to do is to calculate the mole fraction. Then we'll calculate the mole fraction. We'll calculate the partial pressure. Now the mole fraction has to do with the number of moles of what? One of the reactant, the number of moles of the reactant or product divided by the total number of moles of the reactant and product. So we need to calculate the equilibrium mole, the total equilibrium mole for the reactant and the product. So the equilibrium mole will be what? B minus X, total equilibrium mole, plus what? X over 2 plus what? X over 2. So SCM is equal to what? 2. 2 into 1 will give you 2. 2 times 2b minus 2 times b minus x will be equal to 2b minus what? 2x. 2 into 2 give you 1. 1 times x plus x. 2 into 2 give you 1. 1 times x is what? Plus x. So minus 2x plus x is minus x plus minus x plus x is equal to what? 0. So we'll have 2b over 2. So 2 cancel 2. So the total equilibrium mole is equal to b. So what we have to do now, we have to calculate the mole fraction for each of the reactant and the product. So since we have the total equilibrium mole of the reactant and the product. So the mole fraction for hydrogen iodide will be equal to what? B minus X divided by B. Mole fraction for hydrogen gas will be equal to what? X over 2 divided by B. The mole fraction for iodine gas will be equal to what? X over 2 divided by B. So I have to erase this so that I'll have enough space. So mole fraction for hydrogen, I have to break it then to be what? X over 2. Change the division sign to multiplication. The denominator will go up and the numerator will what? Come down. So we have 1 over B, which will now be equal to what? X divided by 2B. Mole fraction for iodine, the same thing, which is would now be equal to what? X over 2 times 1 over B, which will now be equal to what? X over what? 2B. So the next thing, we'll have to calculate the partial pressure. We'll have to calculate the partial pressure for both the reactant and the product for each of them. And partial pressure is equal to total pressure multiplied by mole fraction. Since we already have the mole fraction for each of the reactant and each of the product, the total pressure is P. So partial pressure for hydrogen iodide will be equal to what? Total pressure, which is P, multiplied by the mole fraction, which will now be what? PB minus what? X over what? B if you multiply. Which multiply P times total pressure times the mole fraction, which will now be what? PB minus X over B. I have to erase this so that I'll have enough space. Partial pressure for hydrogen will be equal to what? Equal to P times what? X over 2B, which will now equal to what? P X over 2B. Partial pressure for iodine will be equal to what? P times what? X over 2B, which will now be equal to what? P X over 2B. So I have to erase this so that I'll have enough space. So I'll write the equilibrium expression. The equilibrium expression will be what? Kp will be equal to what? Partial pressure of hydrogen multiplied by partial pressure of what? Iodine divided by what? Partial pressure of hydrogen iodide, all raised to power 2. So now I have to do that. So what we'll have now is okay, let me put this one. Your partial pressure for hydrogen is Px over 2b. Partial pressure for iodine Px over 2b. So I have to erase this so that I'll have enough space to calculate the Kp. So Kp will be equal to what? Px over 2b times Px over 2b divided by what? Pb minus x over b, all raised to power 2. So I have to erase this so that I'll have enough space. So Kp will be equal to what? P square, P times P square, x square over what? 2b times 2b, which will be 4b square, divided by P square times b minus x, all raised to power 2 over what? B square. Over b square. So P square cancel P square. So we'll have I have to erase this. for enough space. So we'll have now, what we'll have here will be what? X squared over 4b squared divided by b minus x all raised to power 2 over what? B squared. So we change the division sign to multiplication. It will now be x squared over 4b squared times what? B squared over b minus what? X all raised to power 2. So b squared cancel b squared. So what will be left now will be equal to what? X squared over 4 times what? Bracket b minus x all raised to power what? 2. So as you can see, so which expression for Kp is correct? The expression for Kp will now be x squared over 4 bracket b minus x all raised to power 2. So the correct answer to this question is what? D. D is the correct answer, which is x squared divided by what? 4 bracket b minus x all raised to power what? 2. So it's as simple as ABC. Attempt as many questions as possible and feel free to reach out to me if you encounter any difficulty, any challenge. I'm Mr. Joseph, your chemistry teacher. I'm always there for you. You can reach out. I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on chemical equilibrium. Before us, a typical A-level chemistry question on chemical equilibrium. So the reaction between sulfur dioxide and oxygen is reversible. From the equation, you have 2 moles of sulfur dioxide gas and 1 mole of oxygen gas to form 2 moles of sulfur trioxide gas. The equilibrium constant Kc is 208 per mole dm cube at 1000 Kelvin. In an equilibrium mixture at 1000 Kelvin, the sulfur dioxide concentration is 0.200 mole per dm cube and the oxygen concentration is 0.100 mole per dm cube. What is the sulfur trioxide concentration? So the first thing we have to do here, we have to look at the values we are giving. We are giving the equilibrium concentration. We are giving the concentration of sulfur dioxide and the concentration of oxygen. So we have to calculate the concentration of sulfur trioxide. So we have to write the equilibrium constant, the equilibrium expression Kc, the equilibrium expression Kc. Kc will be equal to what? Concentration of sulfur trioxide all raised to power 2. That is the expression of our concentration of what? Sulfur dioxide all raised to power 2 multiplied by what? Concentration of oxygen. The square bracket is an indication of concentration. So that is the equilibrium expression. So we have to substitute the values. The equilibrium constant is 280 will be equal to, we are looking for concentration of sulfur trioxide. Concentration of oxygen, sulfur dioxide is 0.200 all square multiplied by what? Concentration of what? Oxygen, which is 0.100. So the next thing we'll have to do, we'll have to cross multiply. So make concentration of SO3 the subject of the formula. So we'll cross multiply. We'll have what? 280 multiplied by what? 0.200 square multiplied by what? 0.100, then all square roots. So concentration of S sulfur trioxide, let me use my calculator, 280 multiplied by 0.200 square multiplied by 0.100 square. So we'll have what? Square root. The square root will be 1.12. So concentration of SO3 will be equal to what? Square root of 1.12 will be equal to what? 1.0583 mole per dm cube. So the correct answer to this question is what? A. The answer is A. It's as simple as ABC, which is 1.058 mole per dm cube approximately. So as you can see, it's very, very simple. Attempt as many questions as possible and feel free to reach out to me if you encounter any challenge or any difficulty. Hi guys, I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures. Today we'll be looking at a typical examination A-level questions on chemical equilibrium. It has to do with calculation of what equilibrium constant. When we talk about equilibrium constant, it is the product of the concentration of the products raised to power of the number of moles divided by the product of the concentration of the reactant raised to the power of what number of moles. So the question before us, 0.200 mole of sulfur dioxide and 0.200 mole of oxygen are placed in a 1 dn cube sealed container. The gases are allowed to react until equilibrium is reached. 2 moles of sulfur dioxide react with 1 mole of oxygen to give you 2 moles of sulfur trioxide, that is sulfur 6 oxide. At equilibrium, there is 0.100 mole of sulfur 6 oxide in the container, which is sulfur trioxide, SO3. What is the value of Kc? So the first thing to do to attempt this question, you write the equilibrium constant. The equilibrium constant Kc will be equal to what? Concentration of what? Sulfur trioxide, all raised to power 2, divided by what? Concentration of sulfur dioxide, which is sulfur 4 oxide, all raised to power 2, multiplied by what? Concentration of what? Concentration of oxygen. So this is the equilibrium constant Kc. Now, at equilibrium, there is 0.1 mole of sulfur trioxide in the container. What is the value of the equilibrium constant? So this is the equilibrium expression for this particular reaction. You write the expression for the equilibrium constant, which is the concentration of the product raised to the power number of moles divided by the concentration of the reactant, which is the product of the concentration of the reactant raised to the power of what number of moles. Now, from our equation, the initial mole, I use Im to represent initial mole. Initial mole of sulfur dioxide is 0.2. Initial mole of oxygen is 0.2. Here, 0 sulfur trioxide. Then now say at equilibrium, then we'll write the equilibrium mole. Equilibrium mole for sulfur trioxide, which is sulfur 6 oxide, is 0.1 mole. So we have to look for the equilibrium mole of sulfur dioxide, which is sulfur 4 oxide, and equilibrium mole for oxygen. So we are going to use the stoichiometry of the equation to determine what the equilibrium mole for the reactant, which is SO2, sulfur 4 oxide, and oxygen. Now from the stoichiometry, 2 mole of sulfur 4 oxide react with what? 1 mole of oxygen. So let's say now, if whenever 2 mole of sulfur 4 oxide, to get the equilibrium mole for sulfur 4 oxide, whenever 2 moles of sulfur 4 oxide react, 2 moles of what? Sulfur 6 oxide is formed. So 2 moles of SO2 react to form what? 2 moles of SO3. So whenever 2 moles of SO2 is formed, 2 moles of SO2, whenever 2 moles of SO3 is formed, 2 moles of SO2 must have reacted. So when 0.1 mole of SO2 is formed, then 0.1 mole of what? SO2 must have what? Reacted. So the equilibrium mole will be equal to what? 0.2 minus 0.1. That's what will be left at equilibrium. So 0.2 minus 0.1. This one will be what? 0.1. Now to get the equilibrium mole for oxygen, now we'll look at the equation. Whenever 1 mole of oxygen reacts, 2 mole of what? SO3, which is sulfur 6 oxide, is formed. So if for formation of 0.1 mole of sulfur 6 oxide, how many mole of oxygen must have reacted? So the number of mole of oxygen must have reacted would be 0.1 divided by 2, which will now be equal to 0.005. 0.005. Let me use my calculator. 0.1 divided by 2. 0.1 divided by 2 divided by 2, which is equal to 0.05. Yes, not 0.005, but 0.05. I think I have to erase this so that I have enough space. That means 0.05 moles of oxygen must have what? Reacted. So what we left at equilibrium will be 0.2 minus what? 0.05. So 0.2 minus 0.05 minus 0.05, 0.05, which will now be equal to 0.2 minus 0.05. So we'll have what? 0.15 mole of oxygen will be left at equilibrium. So that means the equilibrium mole for SO2 is equal to what? 0.1. The equilibrium mole for oxygen is what? 0.15. Then the equilibrium mole for SO3, it has been given to us, which is what? 0.1. So we have to calculate what? Calculate the value of the equilibrium constant. So I have to erase this so that I'll have enough space to solve. So let me erase this. So the equilibrium constant Kc now will be equal to what? Concentration of what? SO3, which is equilibrium mole 0.1 divided by 1, which is concentration, because the concentration is in mole per dn cube. So you have 0.1 mole divided by 1 dn cube, which is the volume. So you get the concentration in mole per dn cube. All raised to power 2 divided by what? Concentration of what? Concentration of SO2, all raised to power 2. So which is 0.1 divided by 1, all raised to power what? 2 multiplied by what? Concentration of what? Oxygen, which is 0.15 divided by 1, which is the equilibrium concentration. So I have to erase this so that I can have enough space to carry out my calculation. So what will be Kc? Now the value for Kc will be equal to what? Equal to 0.1 square over 0.1 square times 0.15. 0.15. So I have to erase this so that I'll have enough space to carry out my calculation. So to calculate the equilibrium constant, Kc now will be equal to, so I have to use my calculator, 0.1. So you have what? 0.01. 0.01 divided by what? 0.01 times 0.15. So it will now be 0.01 times 0.15. So you have 0.0015. So it will now be 0.01 divided by 0.015. So let me use my calculator. 0.01, 0.01 divided by 0.0015. So which will now be equal to what? 6.67. 6.67 watt mole per watt dm cubed. So I have to erase this so the answer to this question is what? D. So the value of the equilibrium constant is 6.67 moles per mole dm cubed. So the answer is what? D. So it's as simple as what? ABC. Attempt as many questions as possible and feel free to reach out to me if you encounter any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. So feel free to reach out to me. Have a nice day. Thanks. Hi guys, I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on chemical equilibrium. So before us, it's a typical A-level questions on chemical equilibrium. So hydrogen and iodine can react reversibly to produce hydrogen iodide. The equation is shown. You have 1 mole of hydrogen gas reacting with 1 mole of iodine gas to give you 2 moles of hydrogen iodide gas. There are 4 mole of hydrogen gas and X mole of iodine vapor are mixed in a sealed container of volume 1.00 dm cube at a temperature of 460 Kelvin. The system is allowed to reach equilibrium. The equilibrium mixture contains 2 mole of hydrogen iodide. The equilibrium constant Kc for the reaction at 460 Kelvin is 4.0. So you're asked to calculate the value of X. That is the initial mole of iodine. So that which is the value of X. So the first thing to do is to write the value of the equilibrium constant. The equilibrium constant, which is Kc, equilibrium constant Kc will be equal to what? The equilibrium constant is the product of the concentration of the product raised to the power of number of moles divided by the product of the concentration of the reactant raised to the power of number of moles. So if I have to write the equilibrium constant here, it will be a concentration of what? Hydrogen iodide, all raised to the power 2, divided by what? The concentration of hydrogen gas multiplied by the concentration of what? Iodine vapor, which is iodine gas. So we are given the initial mole of hydrogen. Initial mole of hydrogen gas is what? 4. The initial mole of iodine is X. Then initial mole for hydrogen iodide, so we don't know how to put 0 here. Then we have to calculate the equilibrium mole. Equilibrium mole, we are given the equilibrium mole for hydrogen iodide, which is 2. So we have to calculate the equilibrium mole for hydrogen gas and iodine gas. We have the equilibrium mole for hydrogen iodide. So from the stoichiometry of the equation, look at the stoichiometry. 1 mole of iodine, hydrogen gas reacts with 1 mole of iodine to give you 2 moles of hydrogen iodide. So whenever 2 moles of hydrogen iodide is formed, 1 mole of hydrogen gas must have reacted. So what will be the number of mole of hydrogen gas that is left at equilibrium? It will be what? 4 minus 1. That means the number of mole of hydrogen gas left at equilibrium is equal to what? 3. It's as simple. 1 mole of hydrogen gas react to give you 2 mole of hydrogen iodide gas. So whenever 2 mole of hydrogen iodide gas is formed, 1 mole of hydrogen gas must have reacted. So the number of mole of hydrogen gas that will be left at equilibrium is 4 minus 1, which is equal to what? 3. Now let's go for iodine. When 1 mole of iodine reacts, 2 moles of hydrogen iodide gas has been formed. So whenever 2 mole of hydrogen iodide gas is formed, 1 mole of what? Iodine gas must have reacted. So what will be left at equilibrium will be what? X minus 1. The number of mole of iodine gas left at equilibrium is X minus 1. So for hydrogen, the equilibrium mole is what? 3. For iodine, the equilibrium mole is what? X minus 1. Then for hydrogen iodide, the equilibrium mole is what? 2. So we have to calculate the value of what? X, which is the value of what? Iodine gas, which is the initial mole of the value for what? Iodine gas. So we're going to use equilibrium constant, the expression for the equilibrium constant. So I have to erase this so that I'll have enough space. So equilibrium constant, we are given the value of the equilibrium constant. Value for the equilibrium constant is 4, will be equal to what? Concentration of hydrogen iodide at equilibrium is 2 all raised to power 2, divided by the concentration of hydrogen at equilibrium is 3, multiplied by the concentration of concentration of iodine gas at equilibrium is what? X minus 1. So cross multiply, you now have what? 2 raised to power 2 is 4, which will be equal to what? 4 bracket. 3 times x is what? 3x. 3 times minus 1 is minus 3. So if you clear the bracket, you now have 4 is equal to 4 times 3x is 12x. 4 times 3 is what? Minus what? Minus 12. So I have to erase so that I'll have enough space. So what we'll have now is what? You collect like terms. That means 4 will be equal to what? We have 12x minus 12. So if we are to collect like terms, it will now be 4 plus 12 will be equal to what? 12x. That's where minus 12 crosses over to this side to change to what? Plus x. So 4 plus 12 is what? 16 is equal to what? 12x. So to get x, we'll divide the coefficient of x by both sides. Divide by 12, divide by what? 12. So x now will be equal to what? 16 over 12. So if I come to use my calculator, you now have 16 divided by 12, which will now be equal to what? 1.33. So x now equal to what? 1.33 mole, which is the mole of what? Which is the mole of initial mole of what? Iodine, which is the value of what? X. So the answer to this question is what? C. C is the answer, which is 1.33 mole. That is the value of the initial mole of what? Iodine, which is X, which is 1.33 mole. So it's as simple as what? ABC. Attempt as many questions as possible and reach out to me if you encounter any difficulty. I'm always there for you. Just reach out to me and I'll be there for you. I'm Mr. Joseph, your chemistry teacher. Thank you for listening. Mr. Joe, your chemistry teacher. Subscribe to my YouTube channel, comment, like, share, and reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joe, your chemistry teacher. Subscribe to my YouTube channel. Thank you very much.